This video will be about the data analysis calculation for experiment RK5. Before getting into the experiment and before getting into the calculations, you will need these two files, RK5 data and RK5. Let's take a look at RK5 data. RK5 data has the pH readings with time for 3 tablets and 5 tablets. After that, the properties of the anti-acid tablets. So the active ingredient here is 200 milligrams of aluminum hydroxide plus 200 milligrams of magnesium hydroxide. The mass of tablets here is 3.732. This is in grams for 3 tablets and 6.2390 for 5 tablets. This is the total mass for 3 tablets and the total mass for 5 tablets. Mass of active ingredient is 400 milligrams. Make sure this is, take care, this is grams and this is milligrams. 400 milligrams is per tablet, so the active ingredient here is 400 milligrams, which is basically 200 milligrams of aluminum hydroxide plus 200 milligrams of magnesium hydroxide. To calculate the mass fraction of active ingredient, you have to calculate the mass fraction by dividing the mass of active ingredient in one tablet divided by the mass of one tablet. So mass of one tablet for 3 tablets is 3.732 divided by 3. We are assuming here that the mass of all tablets are equal. Molecular weight of active ingredients, you have to calculate the molecular weight of active ingredients. Assume that there is a mixture of 200 milligrams aluminum plus 200 milligrams of magnesium, so the total weight is 400 milligrams, and you have 2 components in the mixture, aluminum and magnesium. You should calculate the average molecular weight, and the mass fraction here will be 0.5 for aluminum and 0.5 for aluminum hydroxide and 0.5 for magnesium hydroxide. Typical thickness H here is given here for 3 tablets. The first tablet is 4.87, the second tablet is 4.8, third tablet is 4.86, 5. This is in millimeters. Calculate the average thickness. Same here for diameter is 6.07, 16.07, 16.13, 16.117. Calculate the average diameter. So here is the average diameter, here is the average thickness, and here is the average diameter. The aspect ratio will be H over R. So this is the diameter divided by 2 to get the radius. And then the density of the tablets is the mass of one tablet divided by the volume of one tablet, which is the volume of a cylinder. So the first report requirement for the experiment RK5 is use equation 9 to elevate the concentration at various times. So we'll go here at RK5, the PDF RK5. So basically the first equation is pH is equal to minus log Ca. So you have here the pH at each time. Just plug in the pH here and calculate Ca at each time. So you will have a table like this: time, pH, and then concentration, which is calculated from this equation. The second requirement in this experiment is substitute Ca into equation 10 and determine the radii at various times. So equation 10 here is this one. R radius at various times is equal to RQ, big capital RQ plus MB Ca. Ca here is the concentration at each time, minus Ca node which is the initial concentration. 2 alpha is the aspect ratio which you should get from here. Density is the pi is pi, m is the number of tablets, rho is the density. You should calculate it from here. And then xp is the mass fraction, which you will calculate here. So all the inputs for these equations are known. The only thing changing is Ca with time. So you will have another column. So you'll have pH, concentration, and then radius at various times. Report requirement will be use equation 7 to determine the order n and value of combined mass transfer and kinetic rate constant K by and combined mass transfer and kinetic rate constant A by plotting ln minus dr by dt versus ln Ca. You can approximate dr by dt by del r divided by del t. So let's get back to the PDF RK5. So after calculating the pH, after calculating the concentrations and calculating the R, using equation 10. Now you have to calculate minus delta R by delta T. How to calculate delta R, del R, this one. This one is calculated by subtracting, for example, the R at 1 minute minus R before it. Obviously, the first one would be 0 because R minus R is 0. And then the third one will be this one at 130 seconds minus the previous one, the same at 2 minutes, the R at 2 minutes minus the R at 130. Obviously R is decreasing, so delta R between each two times will be a negative. That's why we have a negative here. The same thing with the time. You have 1 here minus 0, so here will be 1. The second one will be 130 minus 1, so here will be 30 seconds, and then 30 seconds, and so on. So you divide delta R minus delta R by delta T to get minus delta R and delta T. Now you calculate ln minus delta R with delta T and ln CA. From equation 7, when you linearize it using ln, you will have this. Ln minus delta R by dt is equal to ln K plus 1 alpha MBV 3 alpha rho XP. We want this K. Every other input in this equation is known. The only unknown is K and N. When you plot ln minus dr by dt with ln CA, which is this one and this one, the slope will be N, and the y-intercept will be all of this. So you have all the knowns. If you know all the knowns here, you know what is MB, V, XP, rho, alpha 3. The only unknown is K, so calculate K. Thank you. Goodbye.